Hey everyone, and welcome back to the channel. Have you ever wondered how AI can look at the picture and not only understand what's in it but also describe it in a detailed sentence or even answer your question about the image? This is possible because something called vision language models. And today we are going to deep dive into a really important one that helped save the entire field of vision language model. We are talking about BLIP, which is made by Salesforce, which stands for Bootstrapping Language Image Pre-training. BLIP was a game changer when it came out in 2022 because it created a unified way for a single AI model to get good at both understanding image and generating text about them. This was a huge step forward and helped build the foundation for many of the powerful models we see today. So, in this video, we are going to break down about BLIP and teach you how you can implement BLIP on your own. First, we should see its research paper. Let's get into it. Let's review the research paper of BLIP. It stands for Bootstrapping Language Image Pre-training for Unified Vision Language Understanding and Generation. So, what is BLIP? BLIP at its core is a framework for pre-training an AI model on a massive amount of image and text at the same time. The goal was to create a single unified model that could handle a wide variety of tasks that involve both vision and language. So, what were the problems that gave part to BLIP creation? Uh, Before BLIP, most models were specialists. You had some that were great at understanding based tasks like matching a sentence to the correct image out of a big pile. We call this image text retrieval. Then you had other models that were great at generation based tasks like writing a caption for a photo. The problem was a model that was good at one, usually not so good at other. It's like having a great listener who couldn't tell us good story, or a great storyteller who was not a good listener. This created a divide in the field. So, what solution were presented by Blake? The researcher at the Salesforce came up with two brilliant solution to tackle this. First, they created a new model architecture they call multimodal mixture of encoders and decoder, called MED. This is a fancy way of saying they built a flexible model that can switch between different modes depending on task. Second, to deal with the fact that a lot of image text data scrap on the web is messy and inaccurate, they invented a technique called captioning and filtering, or CAPFIL. This is a clever way for the model to clean up its own training data. So let's break down each of this. At the heart of the BLIP, it's a unified architecture. Think of it as a Swiss Army knife. It has different tools, but they are all part of the same ha handle. The MED architecture can operate in three ways. Let's see. Uh, Unimodal encoder. In this mode, it looked at the image and text separately. It learns to create representation or numerical summaries for both, so that the representation for a dog picture is very similar to a representation for a word, a photo of a dog. Second is image ground text encoder. For understanding tasks, this mode encodes the text while paying close attention to details in image. This helps the model figure out if a sentence truly matches the image content in a fine-grained way. Third, image-grounded text decoder. For a generation task like image captioning, this mode uses the image as a guide to generate a new relevant sentence word by word. To get this to work, this model trained on three different objectives at once. Image text contrastive loss. So, What is it? This pushes the model to make the representation of matching image text pair more similar, non-matching pair more different. Image text matching loss. This is a fine grain check. Uh, it teaches the model to determine if a specific piece of text is a perfect match for an image or just loosely related. Language model loss (LM). This is what powers the text generation. It teaches the model to predict the next word in a sentence given the image and the word that came before. So the final is CAPFIL. Now for the second CAPFIL stands for captioning and filtering. The internet is full of image with caption, but a lot of them are low quality or just plain wrong. Training a model on this noisy data can really limit its performance. CAPFIL uh, solve this with a two-step process. The captioner. First, they take the pre-trained BLIP uh, model and use it to generate brand new synthetic caption for all the web images. The filter, then the model switches hat and acts as a filter. It's look at both the original web text and the newly generated caption for each image and decided if the text is a good match for the image. If it's a noisy or irrelevant caption, it gets thrown out. By doing this, BLIP create a massive new dataset that is much cleaner and higher quality. The model literally bootstrap itself to get better data to learn from. So, what are the benefits of the BLIP architecture? So, from technical standpoint, the advantages are clear. You get one unified model for both understanding and generation. It's more computational efficient because different functions share most of the same model's parameters. The CAPFIL method is a game changer for improving data quality, and it's scalable, meaning its performance get even better as you feed it more data. Practically, this means researchers get a versatile, effective, and efficient model that sets new state-of-art performance score across a ton of benchmarks, from image retrieval to visual question answering. Of course, there is no model which is perfect. BLIP has its limitation too. On technical side, it struggled with tasks where these visual concepts were very different from its saw in its web-based training data. When dealing with videos, it just treats the frame as a bag of image without truly understanding the sequence of event or time. There is also a risk of confirmation bias because the same base model is used for both captioning and filtering. It might be too lenient on its own mistake, letting some bad captions slip through. Practically, training BLIP it still requires a ton of computational power. Its performance depends heavily on having access to large-scale data set. So, in my conclusion, BLIP was a thoughtful and practical evolution in vision language model. It wasn't necessarily a huge, uh, great model, but it created a foundation for later more modern and powerful VLM. So, like the clip filled method was a clever solution to the persistent issue of noisy web data, and unified architecture was a forward thinking move that pointed towards the more general purpose AI model that are common today. While it may have been a bit conservative in its ambition, BLIP impact was substantial. It pushed performance benchmark higher and provide a stable, well-engineered foundation that influence a lot of follow-up research in this area. So with this, our review on BLIP is over. Let's get to its implementation. Let's see how you can implement BLIP on your own. So to implement BLIP, first you have to install some required libraries, which are Torque, Transformers, Pillow, accelerate. Let's run this. Hmm. Now let's import these libraries, which are torque transformers. We have to import auto processor, auto model for visual question answering, request from pillow. We have to import image and other these things. So let run this. So next step is to create a helper function. This helper function is solely for this notebook as it helps me to visualize the image I'm going to use for the notebook. So let's run this code. Now, our main function implementing BLIP. First, we have to create a checkpoint. This is the model address in Hugging Face. For BLIP, VQA means visual question answering base. Means this model will help me in visual related question answering. So then I am creating a processor variable and providing it with this model name and a model variable with also with this checkpoint, and also some error variables which is torque dot float float 16 and device map auto. Now I am creating a image variable and storing the uh, image in it using the URL which I have taken using parameter. And next, the question. The question is also a parameter in this function. Then, I am providing these two variables to the processor for the model to perform inference, and then that input is provided to the model to generate the output. That output is again decoded to provide the answer, and now the answer is returned by the end of this function. Let's run this. So our function has been executed safely. Now let's take a sample image. This sample image from the Hugging Face dataset library. So as you can see, this is a image of a cat in a snowy area, which is a blurry image. As you can see, there is not so much information, but there are some information like the area, the image is taken in a snowy place, which is confirmed. So let's provide blip with our question, what is the weather in this image, and the URL of that image. Let's run this. As you can see, our model is getting download. You can see the model saved answers size is around 1.5 GB. Now, as you can see, the answer came out is snowy, which is right for this image. Now, let's take another image. Hmm. This image show a group of sheep on a hilly area in a grassy hilly area, to be specific. Let's ask the very simple question of how many animals are in this image and provide the URL of that image in our function. Let's see the result. 3, which is true. As you can see, there are 3 shapes in this image. Now I've created a set of list which contain various questions related to that image, which are what is the weather in this image, the previous asked question, how many animal in this image, which is this question, which animal is in the image. So it is a sheep. You can see what type of terrain in the image. As you can see, it will be hilly, and any flower in the image, if a model detects a flower, it will say true, or if not, false. And then which time of day it is. So, it's, I think it's a morning or a afternoon, but it's not night. We are sure of that. Let's run this. I have for each question I have run blip and provided with the URL. Now first person, what is the weather in this? It's sunny, it's true, it's and right. How many animal in this image? 3, which is it. Which animal is in this image? Sheep, which is true. What type of terrain in the image? Hilly, and it's surely hilly area. And then any flower in the image? No, the model doesn't find any flower. In this image, I can't also find any flower. So which time of day it is? Afternoon. So it's thinking that the image were taken during an afternoon, which is right because we can't be sure it's day or afternoon. Let's take another sample image. So this sample image, as you can see, this image is of a poster on a wall. Let's zoom out. As you can see, this is a wall side image of a room where there are multiple posters, some video album or a video player device, and a potted plant, and what furniture you can say. So let's ask some visual question on it, like number of poster in this image. Like it will be three. If model taken this as a poster, it is wrong because it's not a poster, it's a video cassette, you can say. Next is name of the device in this image, so what this device it is. And next is on right side poster, what is written on it. Like, so in right side, this is the right side, so this song reminds me of you is written. And any plant in this image, it should be true. Yeah, I can see this is the plant. Let's run this. Our first question, name of the poster, number of poster in this image, three, which is true. Name of the device in this image, record player, which is true. On the right side poster, what is written on it? Music. It's here in the middle poster, it is written music, but on the right side there is something else written. So this is wrong, as you can see. Any plant in this image? Yes. So it's right. So the model was wrong in this question, which has shown its limitation because it was earlier foundation visual language model. So the it has its limitation, but it was a great model at its time. I'm talking about 2022. Let's take another image. Hmm. So this image is of a coin on a table or a cardboard. What can you see? So let's see how visual question answering is good. The visual question answering model is a base model. If there was a large model, you should try it also. Let's see the questions. Number of coins in this image. There are around 13 coins. And what is the color of coins in this image? Silver. What value written on the coin? Majority of coin have one value. And which currency does the coin belong to? It belongs to rupee. And which currency is written on the coin? So it's rupee also. Let's run this. So the first answer is wrong. There are 12 coin. It's showing it's wrong as there are 13 coin. So it's showing its limitation right now. What is the color of coin? It is in image silver. It's true. Value written on the coin one. It's right. Which currency does the coin belong to? British. I don't know how I can say British. It's easily Indian if it's meant a country. Which currency is written on the coin? Pounds. I think the model is hallucinating or anything else you can say because there is not a single coin which is belong to pound. Yeah, all the coins are rupees. So these are the limitation of the British model. Let's get to another image. Hmm. So this image is a very beautiful image of a van in uh, along a beach where two people are on the van. So let's ask some simple question like which vehicle is in the image, which is a van. What is the color of the vehicle? Blue. What is the brand of the vehicle? As you can see, VW means Volkswagen. Number of person in the image. I think there are only two, no more. or where is the person in the image. So on the top of the van, which place is in the image. It's related to beach, so the beach answer it will be right. So what time of day it is, it's around morning or afternoon. So what is the van plate vehicle ID. So I want to retrieve the value, which is 7498. As you can see, it's the plate number of the van. Let's run this. Which vehicle it is, van, which is right. What is the color of the vehicle, blue. What is the brand of vehicle, Volkswagen. It's true. Number of person in the image, Ford. It's failed miserably. There are only two people in this image. I don't know which other two people it's talking about. So it's wrong there. Where is the person in the image, top of the van. It's right. Which place is in the image, beach. It's right. What time of day it is in the image, afternoon. So according to him it's afternoon, so it's true. You can say. What is the van plate vehicle ID, VW. So it's not extracting data from the plate ID, but it is extracting the logo of the vehicle. So it's saying the van ID is VW, which is a symbol of Volkswagen. Let's change it and make it more specific. Let's see what happened. Hmm. So you can see it's processing. Our questions will be a last we require. So it's still the VW, so the model is unable to grasp the OCR of this plate, which so that it is not OCR value. So it has its limitation. With this, it shows that the BLIP model was a revolutionary foundation model of VLM, but it has limitation. But its approach to problem solving are unique, and the unified architecture was very great at solving multiple tasks like visual question answering or image captioning, which can you perform by changing the model name of Salesforce BLIP equate to Salesforce image captioning base. There is a model present on HuggingFace. So with this, our tutorial on BLIP is over.
For more computer vision or machine learning related tasks, you can check our GitHub, where you will find everything in one place.